Hello, math students. Today we're going to be going over the solving advanced linear equations. This is from Unit 1 of the Edmentum Algebra 1. If you did the last couple of lessons, the last couple of tutorials, practices, and mastery tests, and you did well on them, then this lesson shouldn't be too hard. It's more of the same, just more advanced. So there's going to be a few more tricks we have to keep in mind, or a few more curveballs they're going to throw our way, but I'll walk you through it and it shouldn't be too big of a deal. And so let's go ahead and let's get started. So let's go to the tutorial first and go ahead and go to page 5 where you get the first warm-up question. This is very similar to the ones we did from the last lesson, where we have x's on both sides of the equation. The first thing we want to do is move all our x's together on the same side of the equation. Generally, I like to have all my x's together on the same side of the equation. And remember, whatever you do to one side of the equation, you have to do the same on the other side. So I subtract 4x here to cancel this 4x, but that means I have to subtract 4x on the other side of the equation as well. So that's going to give us 4x minus 8 on the left equals, and then just 12 on the right. From there, we're going to use the addition property of equality to go ahead and add 8 to both sides of the equation, giving us that 4x equals 12 plus 8, which is 20. Lastly, to get x by itself, we're going to divide by 4 on both sides of the equation, giving us that x equals 5. Okay. So here we want to put 5. And once you're done with that, we can go ahead and skip this introduction and these other pages. For here, you'll have to skip through like this. You can go ahead and read this instruction if you want, but you can go ahead and skip it because I'm going to be going over everything in detail. So if you feel like you want to read it, you can. If you don't want to read it, that's fine too. Eventually, you'll get stopped on page 12 where the next set of questions are. So we're going to go ahead and go through this brief activity here. It says, in this activity, you will analyze a practical problem and determine the linear equation that represents it. You will also apply the properties of real numbers and the properties of equality to solve equations. So a bunch of the same stuff we did in the last lesson. Again, just a little more detailed. Let's take a look at this first question here. It says, Jared and Zach are practicing their free throws. Jared attempted X shots and made 75% of them. Zach attempted 10 more shots than Jared did, and he made 80% of them. Together, they made a total of 101 shots. Which equation represents this situation? So the key thing is that when you add the shots that Jared made and to the shots that Zach made, you get 101 shots. Okay. By the way, free throws are like shooting basketballs, right? So let's go ahead and figure out what this equation is going to look like. So let's first look at Jared's free throws. So it says that Jared made 75% of them, and he shot X times. So it's going to be 0.75 times X. This is how many Jared made. It's 75% times however many he shot. Now, keep in mind that to change a percentage to a decimal, I move the percentage twice to the left. So that's where I get this 0.75 from. Now we're going to add in the number of free throws that Zach made. So Zach made 10 more shots than Jared did, and he attempted 10 more shots than Jared did. So remember, Jared attempted X shots. Zach, on the other hand, attempted 10 more than that. So if Jared attempted X shots, then that means Zach attempted X plus 10 more. Okay. And Zach's free throw average was better. It was 80%. So I was going to put 0.80 here, multiplied by the number of free throws he attempted. And in total, this gives us 101 made shots. So this should be our equation here. And indeed, we see it right here. Okay, from there, we could solve for x. That's probably going to be the next problem. Yep. So we're going to go ahead and solve for x. Remember, x is the number of shots Jared attempted. Okay, once we find that, then we can figure out how many Zach attempted because we just add 10 to Jared's, right? So let's go ahead and solve this equation. So the first thing I would do is whenever you have a number in front of a parentheses like that, notice I've got 0.80 in front of this parentheses. That means this 0.80 needs to be multiplied by every term in this parentheses. So this 0.80 is going to multiply with x and also with this 10. We call this the distributive property because we're distributing or passing out this coefficient that's multiplying times this parentheses. So just keep in mind it multiplies with everything in the parentheses, but not the stuff that's outside the parentheses. So let's go ahead and we'll distribute that 0.80 at 0.80. So 0.80 times x is 0.80x. Then 0.80 times 10, and you're welcome to use a calculator here, but this should just give you 8. We still have 101 on the other side. By the way, if you don't have it already, you should go get pencil, paper, and a calculator and just follow along and write down everything I write. I guarantee you, if you write down everything I write and you follow along, it's going to make way more sense. Okay, so don't cheat yourself. Write down everything, write down your work, write down everything I write and everything I tell you to write also. So we can go and combine these x's together. Notice that we have a 0.75x and we have a 0.80x. Since they both have x, then you can combine those together. So we're just going to add those together. So that's going to be 1.55x when you add those together. We still have a plus 8 equals 101. Hopefully you see from the last lesson that our next step to get x by itself, we're going to go ahead and subtract 8 on both sides of the equation. This is going to help us get x by itself. So we've got 1.55x equals 101 minus 8. That's going to be 93. Then to get x by itself, we're going to go ahead and divide both sides by that coefficient there. So this coefficient in front of x, this 1.55x, that means these are multiplied. 1.55 times x. So to cancel it, you divide by that coefficient. You divide also on the other side of the equation. This leaves us with x equals, feel free to use a calculator on every single problem if you want, 60. Okay, now remember, x is the number of shots that Jared attempted. And we also learned from the problem that Zach attempted 10 more than Jared. So that means Zach attempted 70. Okay. Here we're going to figure out the justification for each step along the way. So we're going to move these into this reasons column and figure out the reasons for each step. So when I look at this problem here, my first step I would do is I would distribute this negative 2/3. So negative 2/3 times x and negative 2/3 times 8, or sorry, times 12. Multiplies negative 2/3 times each of these in the parentheses. And that would give us this next step. Okay, so you see step 2. So how did they go from step 1 to step 2? Well, they use the distributive property. So whenever you're multiplying something times the inside the parentheses like that, that's called the distributive property. I mentioned that before. Now, what would be my next step? So looking at step 2, how did they go from step 2 to step 3? Well, you can see they combined this negative 2/3 x and this positive 1/3 x. They combined those together, giving you negative 1/3 x. So combining things together, what do we call that? Combine like terms. Combine like terms. Hopefully you see that the next step would be to add 8. So adding 8 to both sides of the equation. So that's the additive property of equality. Let's see. Here, it looks like they multiplied by negative 3 on both sides of the equation, multiplied by negative 3 on both sides of the equation. So that's multiplication property of equality. Lastly, you see how this says negative 6 equals x? I would be fine, and most math people, I think, would be fine if you wrote your answer like that. But they have you switching it to x equals negative 6. I don't know why, but just know that you could always flip that, right? You could always say like 1 plus 4 equals 5, and you could also say 5 equals 1 plus 4. So you could always switch that around the equal sign there. And that's what they're doing here. So that's going to be that the property that allows you to do that is the symmetric property. So just keep that in mind, that you could flip back and forth on the equal sign. Honestly, it doesn't matter. These both say the same thing in my eyes, but it's the symmetric property that allows you to do that. Okay, so you can already see from the last lesson that these equations are a little more complicated. Okay, and we're going to have some more fractions to deal with. Don't worry, don't be alarmed. It's not too bad. I'll show you how it works. So in a problem like this, where we're going to solve for p, I want you to notice first that we have two fractions that equal each other, right? It says p plus 1 over 2 equals 3p plus 7 over 5. Now, whenever you have two fractions that are equal to each other like this, this is called a proportion. So what we have is a proportion. And one thing you could always do with proportions is you could do something called cross multiplying. You've probably seen that before in previous math classes, is that you can cross multiply a proportion. So here you can multiply this one's numerator with this one's denominator. So p plus 1 times 5. I'm going to write the 5 in front. And we actually write this p plus 1 in parentheses because the 5 multiplies with both of these terms, with the p and also with the 1. Similarly, we put equals and we cross multiply the other way. Cross multiply the other way. So 2 times 3p plus 7. 2 times 3p plus 7. Okay. From here, we need to use the distributive property to multiply this 5 into this parentheses. And also we're going to multiply this 2 and distribute it into this parentheses. So 5 times p, we just write as 5p plus 5 times 1, which is 5, equals 2 times 3p is 6p, plus we need to multiply 2 times 7, which is 14. Okay. From here, it's very similar to what we did in the last lesson, where we have p's on both sides of the equation. So I'm going to move all my p's together on the same side. You can move them all to the left or move them all to the right. It honestly doesn't matter. Okay. In my case, I'm going to move them to the right here. Subtract 5p. That means I have to subtract 5p to the other side. 5 equals 6p minus 5p is 1p. We also have this plus 14 here. To help me get p by itself, we're going to go ahead and subtract 14 onto both sides of the equation. Remember, whatever you do on one side of the equal sign, you have to do the same thing on the other side of the equal sign. That gives us -9 equals 1p. Now, notice I'm writing 1p. Some of you already probably are telling me, but that 1 is not necessary. So when you have a 1 right in front of a variable, that's 1 times the variable. Well, multiplying by 1 doesn't do anything. So you don't need that 1 there. So p equals -9. And there you go. Good. Let's go ahead and skip ahead to this page, page 20. And here we're going to talk about sometimes equations, they actually have no solution. So this is a possible outcome, is that when you try to solve something, you end up with no solution. Now, how do you know when it's no solution? Well, we're going to explain that. All the ones we've done so far, like in the last couple of lessons, they've all had one solution where we would find the answer. X equals something, or N equals something, or P equals something. They all have one solution that we can find. So this is most equations that we are going to deal with have like one solution. But occasionally they have no solution. We'll go over what that means and what that looks like. And sometimes they have infinitely many solutions. And again, we'll go over what that means, what that looks like. So let's go ahead and solve these equations down here. And we're going to put them into no solution, one solution, or infinitely many solutions. We're going to do each one at a time. So let's go ahead and do this one first. It's got decimals in it, but that's not too bad. The first thing I want to look at, and I notice here, is that this right side of the equation, it has a 1.4v minus 3.1v. So these two terms, you can combine those because they both have the same variable. They are like terms. So 1.4v minus 3.1v, which is negative 1.7v. We also have this plus 2.8 on this side. On the other side of the equation, we have a negative 1.7v plus 2.8. Okay. Some of you have already maybe noticed something weird here, but let's continue on and pretend nothing's weird. All right. Now notice there's v's on both sides of the equation. I don't like that. So what I'm going to do is I'm going to move my v's over to the left. So I'm going to add this 1.7v to cancel it. But if I add 1.7v here, I have to add 1.7v here as well. Well, notice it cancels here as well, right? Because those are opposites. They just cancel each other here and here. I'm left with 2.8 equals, and then I just have 2.8. Okay, well, where did v go? Well, notice there's no v in my equation anymore. I'm just left with a plain statement of constant equals itself. Well, is this true? Is this true? Or is it false? So if it's a true statement, then it's going to have infinitely many solutions. Okay. So if you end up with something where it's a true statement and there's no variables here, all the variables cancel, and you have a true statement, then you're going to have infinitely many solutions. If you end up with a false statement here, you'll have no solution. Okay. Well, in this case, this is true, isn't it? Yeah, 2.8 does in fact equal 2.8. This is a true statement. Okay, and there's no variables here. They all cancel. We got a true statement, which means infinitely many solutions. So we're going to go ahead and take this first equation and put it in this infinitely many solutions category. Okay, Let's go ahead and try the next one. Now, if that didn't make 100% sense, don't worry about it. We'll go over more of these and hopefully it'll just continue to make more and more sense. Now, looking at this next one, once again, I see that on the left side of the equation, I've got 4a, and I can combine this with the 2a. They are on the same side of the equation. So I need to combine those like terms, 4a plus 2a, which is 6a. So on this side, we have 6a minus 3. And then on the other side, we have 7a minus 2. Once again, I have a's on both sides of the equation. I don't like that. So I'm going to move all my a's together on the same side of the equation. To do that, let's go ahead and move the a's to the left side. So I don't want these ones on the right. I'm going to go ahead and get rid of them. So I'm going to subtract 7a on the right. And since I did it on the right, I have to do it on the left as well. That leaves me with just -2 on the right. And on the left, 6a minus 7a is -1a. And then we still have a -3 here. The next step here is to use the addition property of equality to add 3 to both sides of the equation, canceling this 3. This gives us that -1a equals -2 plus 3 is 1. Here we have more positives, so it stays positive. Lastly, to get a by itself, we divide by -1 on both sides of the equation. A is -1. So here we got a solution, right? We got an answer. If you get an answer, then that means it has one solution. Okay, it has that solution, -1 in this case. Okay. Let's go ahead and work out the next one here. So this one's case has fractions. Now, if you know me, you know I'm not a big fan of fractions, so I like to get rid of them. You can get rid of all the fractions in your equation by multiplying every term by the lowest common denominator. In this case, when I look at my denominators, I've got fifths and I've got thirds. Here's fifths and thirds. Well, if I've got fifths and thirds, well, what's my lowest common denominator? Well, I'm looking for the lowest number that's divisible by 5 and also divisible by 3. So 15 is that number in this case. So I'm going to multiply every term by 15, and that should cancel out all my fractions. So let's go ahead and multiply every single term, distributing this 15 to every term in this equation. So how do we multiply this whole number, 15, times this fraction? Well, keep in mind, the reason we're choosing 15 is to get rid of the fractions. So each answer that we multiply here should give us no fraction in the next step. Well, we can do is we multiply the 15 times the numerator, the top number, and then divide by the denominator. So 15 times 1 is 15. 15 divided by 5 is 3. So this first term is now 3f minus. Then 15 times 2/3, you do 15 times 2, that's 30. 30 divided by 3 is 10. Equals 15 times 1 is 15. 15 divided by 5 is 3. Keep in mind it's -3 because of that negative there. So -3f. Lastly, 15 times 2/3. 15 times 2 is 30. 30 divided by 3 is 10. So plus 10. Okay, now it's much simpler, isn't it? Okay, so now, once again, I've got f's on both sides of the equation. Whenever I see my variable on both sides, I like to bring them all together on the same side. So I'm going to go ahead and get rid of these -3f's here. I'm going to get rid of them by adding 3f. That cancels them here. And I would have to add 3f to the other side in order to balance my equation. 3f plus another 3f is 6f. So we have 6f minus 10 equals, and on the other side we have 10. To help me get f by itself, I need to get rid of this minus 10. Now, how do I get rid of minus 10? Well, you do the opposite operation, plus 10. Since I add 10 to one side, I have to add 10 to the other side of the equation, giving me 20 on the right. I still have 6f over here on the left. Finally, to get f by itself, we divide by 6 on both sides of the equation. That gives us f equals 20 over 6. I could reduce that. This one doesn't divide evenly. So I would just reduce this fraction. I could reduce each of these by 2, giving me 10/3. Okay. If you leave it as 26, that's fine too. But the main thing here is that you actually got a solution, right? You see how we actually get a solution? That means we have a solution. We have one solution. Okay. So if it actually gives you a solution, then that's one solution. Okay. I know this is taking some time, but it's good practice for us. Okay, this one's got a little bit of nuance that I want to explain here before we get started. Notice on the right side of this equation, I want you to look over here. Notice this says 5 plus 2, and then parentheses y minus 1. So I want you to think about this question. Should I add first? Should I do 5 plus 2 and then say, oh, that's 7, and then multiply by y minus 1? Or should I distribute first, multiplying this 2 times each of these terms? Should I do that first? Well, remember your order of operations. You want to do parentheses, exponents, multiplication and division, and then adding and subtracting. Okay, so you do multiplication and division first, then adding and subtracting. So you want to do this multiplication. This distributing is multiplication. So we want to do that first before you add the 5. Okay, so let's go ahead and distribute this 2 here. The 5 doesn't do anything, but let's go ahead and distribute this 2. 2 times y is 2y. 2 times minus 1 is minus 2. On the left side, nothing has changed. We can't combine those because they're not like terms. Looking back on the right side, we can combine this 5 and minus 2. What's 5 minus 2? Well, that's 3. So we have 3 plus 2y over here on the right. On the left, we have 2y minus 3. Okay, what's my next step? Well, do you see how there's y's on both sides of the equation? I don't like that. I'm going to go ahead and get rid of these y's on the right. The way I get rid of them is subtracting 2y. If I subtract 2y here, then I have to subtract 2y on the other side. Well, that actually cancels that too. So what I'm left with is negative 3 on the left equals 3. Now, notice my y's are all gone. All my y's canceled. All my variable has canceled. But am I left with a true statement or a false statement? Well, this is a false statement, isn't it? Negative 3 equals 3. Well, that's false. These are not equal. So if you end up with something that's a false statement, that means you have no solutions. Okay, no solution. So again, as a reminder, if you end up with something that's always true, like 3 equals 3, then that's infinitely many solutions. But if you end up with something that's not true, like 3 equals negative 3, that's not true. That's no solution. Okay, last one. Okay, you could probably already see what I'm going to do first. we're going to distribute this -3 into this parentheses and also distribute this -2 into this parentheses. So -3 times n is -3n. -3 times 4 is -12. We also have a plus n on this left side. That does not get left out. -2 times n is -2n. -2 times 6 is -12. I hope you're writing this all down and working them out as we go. Okay. On the left side, we can combine this -3n and this n. I can combine those together. What do those combine to make? Well, those make -2n. So we have a -2n minus 12 equals, and on the other side, we have a -2n minus 12 as well. Here I've got n's on both sides of the equation. So I would like to get rid of, let's get rid of these 2n on the right by adding 2n. Since I add 2n here, I have to add 2n to the other side. Well, that cancels this as well. I'm left with -12 equals -12. Well, that's a true statement, isn't it? Yeah, -12 is equal to -12. And all my variables are canceled. So if you know with a true statement, that's infinite solutions. Let's go ahead and submit to double check. Correct. Great. Okay. Now, hopefully, I think you're going to be ready for the practice and then the mastery test. So go ahead and click on the practice, and you should see these questions here. I'm going to go over every question in the practice. As far as the mastery test, I will give you some of the answers, and for some of them, I'll just give you a hint or the first step or something. Okay, but let's go ahead and get started with this very first question. This is from the practice. So after the tutorial, you want to do the practice. Then after that, then the mastery test. But let's do the practice first. All right. Micah is keeping track of how much he spends this month on gas. In the first week, he bought X gallons of gas for $2.39 per gallon. Yeah, I wish it was that price. In the second week, he bought 3 fewer gallons of gas than in the first week. And the price went up a little bit for $2.49 per gallon. So far this month, he has spent a total of $46.21. Now, when I'm reading these problems, the one thing I like to think about is, notice it says in total, yada, yada, right? So that tells me that's going to go on one side of the equal sign. So I'm just going to go ahead and throw that by itself on one side of the equal sign. Okay. Now, then I start looking at the other stuff. So he bought X gallons of gas at $2.39 per gallon. So that's $2.39 times X gallons. So it's $2.39 for each gallon. That's what per means. It means for each. So when you see $2.39 per gallon, it's $2.39 for each gallon. And we don't know how many gallons that is yet. It just says there are X gallons. So it's $2.39 times the number of gallons, which all we know as is X for now. Notice in the second week, he bought 3 fewer gallons. So in the first week, he bought X gallons. In the next week, he bought 3 fewer than that. So in the next week, so I'm going to put plus, the price for next week was $2.49. But this time he didn't buy X gallons. He bought X minus 3. So 3 fewer gallons that week. Okay. Hopefully you see that the next step would be to distribute this 2.49 times both the terms in this parentheses. We're going to distribute. So we got 2.39x plus, let's distribute here, so 2.49x minus, and we're going to do 2.49 times 3, 7.47. And on the right side of the equation, nothing has changed. Okay. What's my next step? Well, on the left side, I can combine these two terms because they both have an x attached. That means they are like terms. So 2.39 plus 2.49 gives us 4.88x. We still have this minus 7.47 equals $46.21. What would be my next step here? Well, I'm trying to get x by itself. So I'm going to go ahead and use the addition property of equality to add 7.47 to both sides of the equation. This gives us that 4.88x equals, and I'm going to add this together. $53.68. Okay, what's my next step here? Well, I'm going to divide both sides by this coefficient, 4.88. This will leave us with just x here. That's what we want. And then divide this. So divided by 4.88, 11. So the number of gallons he bought for the first week is 11. So x is 11. On the second week, he bought 3 fewer gallons. So 11 minus 3, 8 gallons the second week. Okay. Question 2. Here we have 5d plus 11 equals 8 minus 3d. If you wanted to solve this one, if I wanted to solve this, what would I do first? Well, if you know me, you know I do not like variables on both sides of the equation. So what I would do first is I would add this 3d to both sides of the equation. Okay. And you see, that's what they did as well. They added 3d to both sides of the equation. So what property allows us to do that? That's the addition property of equality. If you add to both sides, that's the addition property of equality. Henry uses these steps to solve this equation. Okay. Between which two steps did Henry apply the distributive property? So it looks like he distributed right here, which is good. You usually want to distribute in the very beginning of your problem if you can. So when I see that distribution that needs to happen, I just go ahead and do it right away. That's usually what you want to do first. And that's what Henry did between steps 1 and 2. He did the distributive property. Which statement is true about this equation? The equation has one solution. Okay. Well, we're going to have to solve this one. And one thing to keep in mind here, notice there's a negative in front of the parentheses. See this negative here? There's a negative in front of this parentheses with the 2x plus 4. Does that negative get distributed? Yes. So this negative applies to everything in this parentheses. Okay, that changes everything in that parentheses is going to change signs. So positives turn to negatives, negatives turn to positives. So This negative is going to change this to a negative 2x and then a minus 4. We still have a plus x here on this side. On the other side of the equation, we have 3x minus 4x minus 4. Now, what would be my next step? So after distributing, you generally want to look for, is there anything I can combine together? So are there any like terms that I can combine together? In this case, yes, there are. We can go ahead and combine this negative 2x and this x. So we can combine the negative 2x and the x on the left side. This gives us negative 1x. We still have a minus 4 here. On the right side of the equation, we can combine this 3x minus 4x, since they both have x. And you just combine the coefficients. So 3 minus 4 is negative 1x, and then minus 4. Here we have x's on both sides of the equation. I don't like that. So I'm going to go ahead and add 1x here to cancel it. But of course, if I add 1x there, I have to add 1x on the other side as well. This gives us negative 4 equals, and then negative 4. This is a true statement, isn't it? So if all our variables cancel and we're left with a true statement, then we have infinitely many solutions. Okay. In fact, any number you choose, you could pick any number and it would work for this equation. Okay. Question 5. The sum, that means we're adding together some things. The sum of 2 times a number. Notice it says 2 times a number, right? When it doesn't tell you the number, that means that's where your variable goes. So we're going to call this x, where it says a number or the number or something like that. That's usually your variable. Notice we have the sum, so we're going to add some things together of 2 times a number. So 2x, that means 2 times a number, and 10. So we're going to sum together 2 times a number and 10 is the same as, well, that's equals, is the same as 6 times the difference of the number, there's x again, and 1. The difference, that's why I'm subtracting, the difference of the number and 1. That was kind of a complicated one to translate into math. But what do you suppose my first step here would be? Well, I hope you agree that my first step will be to distribute this 6. So the 6 multiplies with the x and also with this minus 1. So that's going to be 6x minus 6. On the left side of the equation, nothing changes. Okay. Again, I don't like having x's on both sides of the equation. So I'm going to go ahead and subtract 6x to cancel here. That way I don't have any x's on this side. But if I subtract 6x here, I have to subtract 6x to the other side to keep it equal. That gives me negative 4x plus 10 on the left. And negative 6 is what's remaining on the right. Then we subtract 10 to cancel this. Subtract 10 on the other side to keep it equal. That's negative 16. I know it says minus, but these actually kind of add together because they're both negative. Lastly, to get x by itself, we're going to go ahead and divide by negative 4 using the division property of equality, giving us that x equals a negative divided by a negative is positive. Just like a negative times a negative is also positive. Okay. Multiplying and dividing both follow that rule is that a negative times a negative or a negative divided by a negative is always positive. Okay, so x is 4. Here we go. Okay, here's one where we have this proportion. Remember, we saw one like this before. Let's go ahead and the first step we want to do is cross multiply. So this p plus 1 multiplies with the 4 from the other fraction. I'm going to go ahead and put the 4 in front. Now I'm putting this parentheses here because the 4 multiplies with both the p and the 1. Equals. Then you cross multiply the other way. 3 times p plus 1. Okay. What's going to be my next step? Well, I hope you agree that we're going to distribute this 4 here and distribute this 3 here. 4 times p is 4p plus 4, because the 4 multiplies with the 1, equals 3p plus 3. Here I've got p's on both sides of the equation, so I'm going to go ahead and subtract 3p here to cancel it. That way I won't have any p's on one side. To keep it balanced, I have to subtract 3p to the other side. This is the subtraction property of equality. I hope you're writing down everything I'm writing. By the way, 1p, the 1 is not necessary. Lastly, to get p by itself, we're going to subtract 4 on both sides of the equation, giving us that p equals -1. Okay. Just write down everything I write. I promise it'll help. Okay. The ratio of adults to students on a class field trip is 2 to 5. So I'm going to write a ratio here, 2 to 5. Okay. If there are 12 more students than adults, okay, so this is adults on top, right? This is adults to students, so adults to students. If there are 12 more students than adults, which proportion and solution represents this situation? So for the number of adults, we're going to say X. And the number of students, there's 12 more than that. So that's going to be X plus 12. Like this. So it's either this one or it's this one. So now we need to solve for X. So we're going to go ahead and what do we do next? Hopefully you see that we cross multiply here. So we're going to multiply across. 5 times X, that's 5X, equals 2 times the sum of X and 12. 2 times the sum of X and 12. What do we do next? We distribute the 2. 2 times X, 2 times 12. 2 times X is 2X. 2 times 12 is 24. Here we have X's on both sides of the equation. I don't like that. So I'm going to go ahead and get rid of the X's on the right side. Subtracting 2X here to cancel. That means I have to subtract 2X on the other side. Leaving us with 3X equals 24. Lastly, to get X by itself, we divide both sides by 3 using the division property of equality. X equals 8. Which of these equations has no solution? Oh, I hope it's the first one. Okay. Here we got a bunch of problems. Let's go ahead and work them out one at a time until we find one that has no solution. Remember, how do we tell if it has no solution? It's when you get a false statement. So something with no solution will end up saying something like this. 0 equals 5 or something. Okay, this is false, right? These are not equal. So if you end up with something like that, where it says 0 equals 5 or -5 equals 5, then we would say it has no solution. Okay. Well, let's go ahead and work this out. What do we do first? Well, some of you might be saying, well, we should multiply by 2 to get rid of this fraction. And indeed, you could do that. But in this case, we're not going to do that, because when we distribute this 1/2, the fraction will take care of itself. And you'll see why. So -1/2 times 8, 8x. So you multiply the 8 times 1, then divide by 2. So 8 times 1 is 8, divided by 2 is 4. So that's -4x. It's negative because of this negative here. So you notice you already don't have a fraction for that first term. We also do -1/2 times 6. So 6 times 1 is 6, divided by 2 is 3, and it's negative because a negative times a positive is negative. So -3. Notice that our fractions already kind of took care of themselves in this case. So it turned out kind of nice there, but we're going to also distribute on the right side. So -3 times 2x is -6x. -3 times 1 is -3. Okay. We can combine like terms on the left side. -4x minus 2x is -6x. So we have a -6x minus 3 equals, and then we have a -6x minus 3 over here as well. I could already see that this one is not going to be our answer. So here we add 6x to cancel it here. That means we'll have to add 6x to the other side as well. This cancels. We get -3 equals -3. This is true, isn't it? So since this is true, this is always true. This one actually has infinite solutions. Infinite solutions. Let's try the next one. Okay. So let's start by distributing this -4 here into this parentheses. -4 times 1/2. So -4 times 1 is -4. Divided by 2 is -2. So we have -2x minus 8 equals, I'm going to go ahead and combine like terms. So I'm going to kind of combine steps here. So I'm going to combine like terms over here. I can combine this -2x and 4x on the right side. That gives us positive 2x. And then we also have a minus 8. Notice there's x's on both sides of the equation. I don't like that. So we're going to go and subtract 2x, canceling the x's here. That gives us -4x minus 8 equals -8. Next, to get x by itself, we're going to add 8 to both sides of the equation, giving us -4x equals 0. To get x by itself, we divide both sides by -4. 0 divided by anything is 0. So x equals 0. Okay, so this one just has a solution. This one has one solution. It's x equals 0. All right, let's hope it's the next one. Okay, hopefully you see our first step will be to distribute here on the left side and distribute also here on the right side. 7 times x is 7x plus 7 times 2 is 14. We also have a minus 3x over here on the left. On the right side, 2/3 times 6x. Okay, so remember, to multiply a whole number like 6 times a fraction, just multiply the 6 times the numerator, then divide by the denominator. So 6 times 2 is 12. 12 divided by 3 is 4. So that's 4x. 2/3 times 3, you do multiply times the numerator, divide by denominator. So 3 times 2 is 6. 6 divided by 3 is 2, plus 2. We can combine like terms over there on the left side. This 7x minus 3x, those are like terms. You just combine their coefficients. So that gives us 4x. We have a plus 14 here on the left. On the right side, we still have a 4x plus 2. I cannot combine those together. I would like to get rid of these x's here on the right, so I'm going to subtract 4x. Since I subtract 4x on one side, I have to do so on the other side to keep it equal. It just so happens to cancel here as well. Giving us 14 equals 2. This is a false statement. 14 does not equal 2. So this one has no solution. All right. Let's go ahead and solve this one. This one's comparatively easy. What we want to do first, I'll just write my problem to the side here. Hopefully you could see, what do you think I would do first here? Well, let's go ahead and distribute this 10. That's what we're going to do first. So 10 times x is 10x. 10 times minus 1 is minus 10. Here on the right side, we have 8x minus 2. Notice there are x's on both sides of the equation. Here there's 10x, and on the right side, there's 8x. I don't like that. I like to have all my x's together on the same side. So I'm going to get rid of these 8x's here by subtracting 8x. Whatever I do on the right side, I have to do on the left side of the equal sign. Leaving us with 2x minus 10 equals, and on the right we have negative 2. Next, we're going to go ahead and add 10 and add 10 to the right as well. This gives us 2x equals negative 2 plus 10. I know it says plus, but we actually subtract these because they're different signs. But it's going to be 8 in this case because we have more positives, so positive 8. Lastly, to get x by itself, here 2 times x, we divide to cancel the 2. Divide on the other side, giving us that x is 4. Last one for the practice. What are we going to do first here? Well, hopefully you see that we're going to distribute into this parentheses. Now I want you to keep in mind, this has a negative 2 in front of the parentheses. Now what that means is we're going to distribute the negative and the 2 gets distributed. So we're essentially multiplying by not just the 2, but negative 2. So the 6n, that doesn't change, but negative 2 times 4n is negative 8n. Negative 2 times 7 is negative 14. We also have a plus 4 here on the left side of the equation. A negative 2 is all by itself on the right. Okay. Keep in mind this negative 2 multiplies with all the terms in the parentheses, but not times this 4 here because it's not in the parentheses. Next, we're going to combine like terms on the left side. So we can combine the 6n minus 8n. That gives us negative 2n. We can also combine this negative 14 plus 4. That's negative 10. On the other side, just a negative 2 by itself. Next, to help us get x by itself, we're going to add 10 to both sides of the equation. Giving us that negative 2n on the left equals 8. Almost done. To get rid of this -2, notice it's -2n. That means they're multiplied together. Whenever the number is right up against the variable, that means they're multiplied. So we cancel that out with division. We divide by -2 on both sides of the equation. 8 divided by -2 is -4. A positive divided by a negative is always negative. It doesn't matter which one's bigger or anything like that. When adding and subtracting, it does matter which one's bigger, but not with multiplying or dividing. Okay. Now that we're done with the practice, I hope you were able to get through it. Hopefully you're following along and writing on your own. If certain problems didn't make sense to you, then try watching those problems again, or maybe try doing it on your own. Now we're going to go over the questions in the mastery test. Now keep in mind, you only have 5 questions on your mastery test. You need to get at least 4 of those correct. I have 20 questions here. You are going to receive 5 questions out of these 20. So I'm guaranteed to go over your questions, but I'm also going to be going over a lot of other different questions. So just follow along. And if you want to complete all these questions, then great. If you just want to skip to the ones that you have, you'll have to find those as we go. But if you just watch the video, it doesn't take that long, and just follow along. That makes the most sense to me. Okay. Arrange the equations in order from least to greatest based on their solution. So we need to find the solutions of these. And we want to put them in order from least to greatest. So we want to find the lowest solution, then the next, then the next. So we're just going to have to solve each of these separately. So let's start with equation A. And let's go ahead and distribute here and distribute here. Okay, so this would be 5x minus 30 plus 3x equals, now when we distribute here, 2 times 3 is 6, 6 over 4. Well, that one doesn't divide nicely, so I'm just going to leave it as 6 over 4x for now. And then fortunately, the 8 does work nicely. 8 times 3 is 24. 24 divided by 4 is 6, so it's minus 6. One thing you could do to get rid of these fractions, actually you see this 6 over 4. So to the side, notice that 6 over 4, it can be reduced by 2. So that'll actually give us 3 over 2, dividing both top and bottom by 2, right? So I'm going to change this out for a 3 over 2. Now, what I would do next to get rid of this fraction is I would just multiply everything by that denominator, in this case, 2. Distribute this 2 to every single term in the equation. This will give us 10x minus 60. Again, we're multiplying everything by 2. Plus 6x equals, when you multiply this fraction times 2, it just cancels the denominator. 3x minus 12. Okay. We can combine like terms here on the left side. 10x plus 6x, that gives us 16x. We also have a minus 60 over here. On the right side, we have a 3x minus 12. I'm going to go ahead and subtract 3x, both sides of the equation. Remember, whatever you do to one side, you have to do to the other. I want to cancel these, so I subtract 3x. I have to subtract 3x here. 13x minus 60 equals, and then over here, negative 12. After that, I'm going to add 60 to get rid of this, to help me get x by itself, which means I have to add 60 over here as well. That's 48 now over here on the right. 13x. We have to divide both sides by 13, giving us that x equals, here we could write it as a decimal, I think makes the most sense. This gives us 3.69. Okay, so this first one gives us that x is 3.69. Go ahead and solve for x on the next two equations and put them in order from least to greatest. Okay, most of these questions I'm not going to do them completely with you. I'm just going to give you some of the steps or some hints usually. Okay. All right, here someone solves this. Okay, here are the steps. Complete the statements below with the process used for steps 1 through 4. So what would be the first step that they did here? Well, they distributed for step 1. That's how we got here. So for this first one, they distributed -2 to 5x and 8. Okay. Next, they subtracted 6x to both sides. Then, right here, they added 16 to both sides, right? Plus 16 to cancel here, plus 16 to get this 30. Then they divided by -16. Okay. Which equation has infinitely many solutions? So again, infinitely many solutions. I'm looking for something that's always true. So where all the x's cancel and you end up with something that's always true. For example, 4 equals 4 or something like that. So if you end up with something like that, where it's always true, then that's your one with infinite solutions. So go ahead and solve each of these and figure out which one has infinite solutions. The ratio of water to flour in bread recipe is 1 to 3. Water to flour. A large batch of the recipe has 5 more cups of flour than water. Water is x. Flour is 5 more than that. So x plus 5. Okay. Now our goal is to solve for x. Okay. So what we would do here first is cross multiply. 3 times x is 3x equals, and then 1 times x plus 5. 1 times anything is just itself. Okay. My next step, hopefully you can see I have x's on both sides. I don't like that, so I'm going to subtract x to get rid of it here on the right. That means I have to subtract x over here. 2x now equals 5. Divide both sides of the equation by 2 to get x by itself. X equals, notice these answers are in like mixed number, but if you use a calculator, you could just divide this. 5 divided by 2, and it's 2.5. So that's 2.5. 0.5 is the same as a half. Hopefully you know that already. Okay, for this one, what would be my first step? Well, I would say your first step would be to distribute this -4. So your first step, you would distribute this -4, that's -8p minus 20. Then you also still have this positive 8p on this side. And then you have equals -11. Combine like terms over here, you can combine this -8p and positive 8p together on this left side, then figure out which of those is correct. For this one, here you have this proportion. So what do we want to do first? Hopefully you remember, we want to cross multiply. So this 2 is going to multiply with 9y plus 8. Similarly, this 5 multiplies with 12y minus 1. Okay, from here, you distribute, and eventually solve for y. I think you got it from there. Haiti rewrote the equation as shown. Okay. Which property did she use to rewrite the equation? You can see that the difference between these two equations, she multiplied this 4 into this parentheses. Which property is that? We've gone over it a lot. A teacher is buying supplies for an upcoming art project. She buys X bottles of paint for $1.29 each. So $1.29 times however many bottles of paint, X many. She buys 8 more canvases than bottles of paint for $1.89 each. So plus she buys canvases. They cost $1.89. And she bought more canvases. That's hard to say. She bought 8 more canvases than bottles of paint. So that's the paint, the number of paint bottles plus 8 more. That's how many canvases. In total, she spent $37.38. Okay. See if you can solve it from there. Which value of X makes this equation true? Essentially, they're asking you to solve for X. We've done this many times. So what would be our first step? Hopefully you see that we would distribute this -8 into this parentheses, giving us -8x minus 40 equals, on the right side, I'm going to go ahead and combine these stuff over here together. So we have a -3x plus an additional 1x. That makes -2x, right? Because these -3 are negative. This one's positive. So they actually subtract each other. We also have a -7 minus 3. That's -10. Go ahead and see if you could solve for x from there. For this one, I'm pretty sure you got it. But for your first step, you're going to distribute this 8. Remember, it's 8 times x and then 8 times -1. Solve it after that. All right, here's a property we haven't covered completely. But notice this, it says Q equals R and R equals S. Therefore, Q equals S. This is known as the transitive property. Okay. Essentially, the transitive property says that if two different things both equal the same thing, that means these two things equal each other. So notice Q equals R, S also equals R. That means Q and S are equal to each other. You can see that there. So that's called the transitive property. Okay. How many solutions does this have? Well, it can't have 4 solutions. It's either going to have 1 solution, infinite solutions, or no solution. Remember, if you actually get an answer, then that's 1 solution. If you end up with something that's always true, like 5 equals 5, that's true. It'll have infinite solutions. If you end up with something that's never true, like -5 equals 5, so this is not true, then you'll have no solution. Okay, let's keep that in mind and then more or less solve it like normal. Which equation has the same solution as the equation above? So you're going to have to solve these guys, unfortunately, and figure out which one has the same solution as this one. I'm going to go ahead and work this one out with you so we can figure out the solution we're looking for. So I'm noticing that W's are on both sides of this equation. I don't like that. So I'm going to go and subtract 14W on both sides of the equation. That way we don't have W's here on the right. 12W minus 14W is negative 2W. We also have this minus 27 here. On the right side, we have negative 34. What do we do next? Well, I would use the addition property of equality to cancel out this negative 27. Remember, we're trying to get W by itself. So we want to cancel that. So getting closer to get W by itself. Negative 34 plus 27 is negative 7. Keep in mind it's negative 7 because you have more negatives in this case. Divide both sides by negative 2. Divide by negative 2 gives you W equals a negative divided by negative is positive. So positive 7 over 2. Or if you like it as a decimal, that's 3.5. You could always divide 7 divided by 2 in the calculator, and it'll give you the decimal. Okay. The reason it turns out to a decimal is because 7 doesn't divide by 2 evenly, right? 7's not divisible by 2. So you're going to end up with a decimal there. So figure out which of those would give you the same answer. I haven't solved this one, so I don't know. But if you get to letter C, keep in mind you would multiply everything by 6 to cancel out your fractions. For this one, you would multiply everything by 14 to cancel out your fractions. Okay, I don't know if it's one of those answers. You might want to try these A or B first to see if you get this. Okay. Here's another important property. This is called the zero product property. If X times Y equals 0, what must be true about either X or Y? So think about if you have two things multiplying and their product is 0. What kind of two numbers could this be? Well, either the X would have to be 0 or the Y would have to be 0. So if this is true, and this is going to come up later in algebra, but don't worry about memorizing it right now, but hopefully it makes some sense that if you have two things multiplying and the result is 0, that means one of these two guys has to be 0. Or X has to be 0 or Y is 0. So one of them has to be 0 in this case. If this is true, then this has to be true. Either X or Y must be 0. They could both be 0 also, but how many solutions does this have? Well, it can't have 7 solutions, I'll tell you that. Remember, it has one solution if it actually you find a solution, it just gives you an answer. It has 0 solutions if you end up with a false statement, something like 5 equals negative 5. That's false, so it would have no solution. You would have infinite solutions if you end up with a true statement, like 8 equals 8. That's true. So that's okay. Your first step here would be to distribute this 2. Keep in mind that the 2 does not multiply with this minus 1. All right, for this one here, the first step would be to distribute this 10, giving us 20x minus 40 equals 100x. For my next step, I think what I would do is I would go ahead and subtract 20 on 20x from both sides of the equation, giving us negative 40 on the left equals positive 80x on the right. Go ahead and solve it from there. It's one of these answers. How many solutions does this have? Well, it can't have negative 2 solutions, that's for sure. So again, like I mentioned before, if you end up with a strictly true statement. You have like 5 equals 5, that's infinite solutions. A strictly false statement like -2 equals +2, and you have no solution. And then if you end up with something like x equals and then a number, then you have that solution, one solution. The one thing you want to keep in mind here is when you distribute here, remember multiplying a whole number times a fraction, you multiply times the numerator and divide by the denominator. So 20 times 4 is 80. 80 divided by 5 is 16, I think. Yeah. So this would be like 16x plus 5 times 4 is 20. 20 divided by 5 is 4. And then over here we have 16x minus 2 on the right side. Go ahead and finish solving it from there. Okay. For this one's not too bad. What I would do first is, notice this left side of the equation has the whole thing divided by 4. So what you want to do is you multiply by that 4 to cancel it. That means you also have to multiply the other side of the equation by 4. Remember, whatever you do to one side, you have to do to the other. That's going to give us 2p minus 29 equals, then on the right side, 4 times 4 is 16. Go ahead and try to solve it from there. Okay, for this one's probably the easiest one I've seen so far. What I would do is subtract 4m to both sides of the equation, canceling the m's here. That gives you 3m on the left equals 3. Go ahead and solve it from there. All right, how many solutions does this have? Well, it can't have 4 solutions, I'll tell you that. It's either going to have infinite solutions, a single solution, or no solutions. Okay. Infinite solutions, that'll be something that a true statement like 2 equals 2. That's a true statement with no x's involved. That'll have infinite solutions. A false statement, something like -2 equals 2. This is false, right? So that's not true. So if you end up with something where there's no x's involved and you end up with something that's not true, that has no solution. And if it has one solution, that just is if you actually get a solution, something like x equals 5 or something. Okay. Now, also keep in mind that when you distribute this 2/3, the 2/3 is going to multiply with this 6x and also with this 6 here. The way you multiply 6 times 2/3, you do 6 times 2, then divided by 3. So 6 times 2 is 12, divided by 3 is 4x. Then 6 times 2 is 12, divided by 3 is 4, so plus 4. Equals, and then on the other side, you still have 4x plus 4. Okay, go ahead and figure out how many solutions from there. Okay, well, I covered everything that's going to be on the practice and the mastery test. Hopefully you're able to get through it. And if you found this useful and you'd like to say thank you, then just subscribe or share this video or my channel in general with someone who would find it useful, like your teacher or one of your fellow students. Okay, well, with that, thanks for watching, and I'll see you guys next time.